Okay, here's galaxy number 2. Again, remember galaxies are large groups of stars that resemble dense solar systems, except that they're made out of thousands and billions of stars, all held together by gravity, and they can be millions of light years apart. Of the billions of galaxies located in there, they come in different shapes and sizes, from a few million stars all the way to 400 billion stars, and the only difference that we've been able to see is that they come in 3 different shapes, maybe size too. Like snowflakes, no two galaxies are alike. In my opinion, probably the most beautiful galaxy are the spiral galaxies, and more particular the barred spiral galaxies. NGC 1300, which I showed you, actually it's going to be right here, showed you on part 1, I think is probably the prettiest galaxy, and I wish it really were up in our sky, although it's 61 million light years away, and we can't even see one that's 2.4 million very well, the Andromeda Galaxy, which is the farthest thing you could see with your naked eye. I drew this one, and I'm having my kids draw it, 100,000 light years across. We're about 30,000 light years away from the center, because this is 50,000, 20,000 out to the center. We have the Galactic Core in the center. We have the halo with globular clusters. Sun located outside, like maybe right in there would be our sun, although our sun's going to be a lot smaller than that dot. I did show this website, Build Your Own Milky Way, where we talked about the parts of the galaxy, the galactic bulge, which is the nuclear bulge, the spiralish arms, the Earth being out there, the older stars being sort of in the center, and the younger, bluer stars located out there. Showed you this picture. This looks a little more like a barred spiral. This is my favorite galaxy, at least that I've seen so far, NGC 1300. This is a view of our galaxy, and we're having a really tough time figuring out what our galaxy looks like. It's sort of like if you could interview your belly button and have your belly button describe how you look. Without seeing much of you, if you can actually see other people, cars and trees and fire hydrants, he could make a guess that you are a person, but doesn't know for sure. And if you are a person, what kind of a person would you look like? They could probably pick skin color because it can see itself, but it can't really see much else. So we're in this galaxy trying to look into the galaxy and trying to figure out what it looks like, and this is our best guess. This is 100,000 light years across. The sun's about 30,000 light years from the center, and in the center there is a supermassive black hole, and that one's got some stars zipping around it. We can actually see it zip around it. If you remember where we talked about Kepler's law, they're going around an elliptical orbit. They're actually speeding up as they get closer, and then they slow down, so we can actually see what they're orbiting around, at least see the area which they're orbiting, but we can't see what's in the center. So a supermassive black hole. Probably one in that galaxy too, and also probably in most galaxies. But this is what we think our galaxy looks like. It's supposed to be a sparred galaxy, but this one looks very much like a barred spiral, which we'll talk about, where the arms spiral off of bars rather than off the galactic center. And again, this is a beautiful barred spiral, actually very tightly wound. So is this one. But this is what a spiral galaxy looks like. The arms spiral out, and they can go clockwise or counterclockwise. This galaxy is actually moving in this direction, which allows these stars to kind of drag behind. This galaxy is moving in the same direction, but other spiral galaxies would be moving in a clockwise rather than counterclockwise. Second grouping, and actually what makes up, this spiral galaxies make up about 20%. I don't know why I'm doing this when I have a spiral galaxies make up about 20% of the known galaxies. Barred spirals make up about another 20%. There's 40, and then elliptical galaxies make up about, maybe I'll try this one. Elliptical galaxies make up about 50% of the known galaxies. And if you think about gravity would tend to make something spiral, or spherical, and elliptical galaxies are flattened spheres. So this should be the most populous, although if you add the spiral galaxies you can get 40%. These are really close to it. But elliptical galaxies actually go from being fairly perfectly spherical all the way into something that looks more like a cigar. This would be an SO, and this is, excuse me, an EO, and this one over down here would be an E7. And these actually have the same things. We have S galaxies and SB galaxies, and they go from A to C in both of these cases. And here's another elliptical galaxy. Elliptical galaxies are usually found to be very old in length, in age. They tend to be more reddish or orangish in color, and because of this, we actually think that they're not creating new stars. What color do you think they'd be? The older stars, remember the HR diagram, the older stars tend to be the more red, orangish colored ones. The last one are what are called irregular galaxies, and these galaxies don't fit as either being a spiral galaxy, you don't see any spiral arms, and they also aren't elliptical galaxies, they aren't anywhere between the EO and the E7 galaxies. And why are they there? Well, astronomers think, like this one, this is actually a colliding galaxy, where you have this galaxy right here, and you have this galaxy right here. So maybe they've actually been changed by something, or maybe they even formed this way. We don't know. But anyway, they don't really have a center, they don't really have spiral arms, they don't have the elliptical shape. These are called irregular galaxies, and they can simply be any shape that you can think of. It's possible that there's actually one that is the shape of a human head. Then we have what are called the local group. The local group is an area close to the Milky Way. Right here, the actual local group, we'll call this one local group number 1, is actually located really close, and you can see there's the Milky Way galaxy. The sun would be located out here. It does allow for the Magellanic Clouds, the large one and the small one. Let me show you what they look like. So here's that galactic center. Sun's located about 2/3 of the way out, 100,000 light years across. They're actually saying 100,000 light years is this way, so they're saying it's 200,000 light years across, and I'm not sure why they say that. We do have length, we have width, and we have height, but located way out here are these Magellanic Clouds. They're located fairly close to the sun section. If they were located over here, it'd be pretty tough for us to see, because there's so much stuff in between us and the galactic center that we don't get to see it visibly. We actually have to use radar to look at it, so we get a false image of the center, and trying to look at the other side, you're not only looking through this densely populated this way, but you're also going to look through a densely populated galaxy coming out this way, so we luck out that these are here. The Stay Puft Marshmallow Man may actually be over here, and we can't see him. Okay, so the local group actually has the Milky Way galaxy, has the Sagittarius dwarf, has the large Magellanic Clouds discovered by Magellan when he actually went on his Earth trip, and when he got down to the southern hemisphere looking up at the Milky Way, he could see these two blobs up in the sky, and they're actually named after him. You can see that there are other dwarf galaxies in there as well. Then we can go to the local group complete, where this one actually is 500,000 light years across. This one is 5 million light years across. This local group actually is half of this distance. So it's like this much of this sky. This one reaches out about 10 times farther, and it actually includes the 3 largest. There are about 30 galaxies in here. These dwarf things that you see in here, the NGCs that you see in here, these are all galaxies. And if you take a look at it, the Magellanic Clouds are going to actually be inside of this very center, probably those 2 dots right there. If you want to look at the largest member of our local group, it's the Andromeda Galaxy, about twice the size of the Milky Way, and you can see there's the Milky Way size, and it is larger. And then the Triangulum Galaxy. Those are the 3 largest of our local group. And again, we're looking out 5 million light years out. Let me give you for instance, if you started in the center here and you had a laser, if you shone it out, take about 50,000 years to get there, and then to go all the way out here, it would take 500,000 years to make it out this distance. 500,000 years from the center is about right there. This one would take another 500,000 for a million, and it would take all the way out to 5 million light years to travel out that far. We're Andromeda Galaxy about 2.4 million light years out, very far away. And this is a picture of the Andromeda Galaxy. I really wish we could see this, but it is so far away, 2.4 million light years, that we only get to see about this galactic center. And it's a very fuzzy looking stellar object. You can actually see this thing in the fall if you look up. I actually look up in the eastern sky to see this. It is in the Andromeda constellation, which is why it's called the Andromeda Galaxy, just like Sagittarius dwarf is because it's there. Triangulum Galaxy is called that because it's looking in the direction of the Triangulum constellation, which is all inside the Milky Way. Okay, then the last thing my kids are gonna learn about is Hubble's tuning fork. You can sort of see why it's called a tuning fork, but basically this was the way he classified galaxies. He said SO galaxies really don't have any shape. EO galaxies are perfectly spherical galaxies, sort of like what you can see here. We have SA galaxies, which are the spiral galaxies, simple tight-armed galaxies like this. And we have SB galaxies, which are this barred spiral galaxy, where the arm seems to come off this bar rather than right out the center. But if you take a look, the spiral arms get more and more spread out as we go from A to B to C, and same here, these barred spiral arms get more spread out as we go. And it's just the way Hubble actually used this as an evolutionary thing, saying that galaxies probably started out this way, and as they started to spin, they spread out, and then they actually maybe got arms one way or the other. But now we just use it as a way of classifying. The irregular galaxies are outside of this arm, and again, they can be any shape you want. Theoretically, it could be the shape of a person, it could be the shape of your favorite car, it could be the shape of an ice cream cone, it could be the shape of anything you want. And here's just another view. This one actually includes galactic shapes, real galaxies that are found. This one just shows you shapes, and you can see E to E7, very much like a cigar, perfectly sphered cigar. And then we have spirals, A tightly spiraled, B's opened up a little bit more, and you can see it doesn't have to do with the number of arms that are there, it's just whether they're tightly packed, and they get opened up as they move to SCs. And then SBs are the barred spirals, and again tight-armed to wider-armed as we go. And if you go back up to NG 1300, looks like it's a tightly packed one. I would probably say this is an SBA to an SBB. Okay, thank you much. Bye.